today we will derive the Rodrigues formula for rotating a vector around a random axis in 3D in the same frame. Suppose I am visualizing a 3D demo. This one, red one is x-axis, green one is blue one is y-axis, green one is z-axis. Suppose this one is the axis about which we want to rotate, and this one, shorter one, would trip. Suppose this is the velocity vector. So initial orientation is this way. So this one parallel component plus perpendicular component. Again, this one is parallel component plus perpendicular component equal to actual velocity. Just a triangle law. Now we are rotating conically. Suppose this angle phi, and we are rotating, maintaining the angle in the plane perpendicular to this circular part here. Say circular part. This circle is in the plane perpendicular to this omega cap axis. So here initial position, and then after we are rotating this way, the new orientation, but angle again remains same phi, but we have rotated theta angle. After that, this one new velocity vector after rotation, we want this one. So for this also, V parallel component remains same, but V perpendicular component rotated by theta. So in this direction, V perpendicular component, in this direction the component is V perpendicular cos theta. It is in the direction of original V perpendicular, and this one is mod of V perpendicular sin theta, but this one is in the direction of original omega cap cross V. So we require direction also. See the figure on this one. But before this, we require this knowledge, basic knowledge. Component of vector A in the direction of B. This one A, this one is B. Suppose this one is P, this one is Q. We want the component of vector A in the direction of B. According to geometry, it is ON. So required component is ON. It is mod A cos theta. Multiplying both numerator and denominator by mod B, we get A dot B upon mod B. But it is the component with plus minus sign. But we require direction also. Then it is called projection. So for projection, we require direction also. So we have to multiply it by B cap because it is in the direction of B. So A dot B upon mod B into B cap is the projection of vector A in the direction of B. We require this formula here. Now whatever shown in a 3D demo, I have drawn figure in a 2D system. This one is the omega cap. This one is original V velocity vector. This one is parallel component, and this one is perpendicular component. So V parallel plus V perpendicular is V. So V perpendicular is V minus V parallel. This one, we have rotated this one. So we want to find new vector, dotted line, after rotation. So it is called velocity vector after rotation. But here phi angle remains same because of we are maintaining angle around omega cap. So consider this one. This is not smaller than this. This is the same angle. Now V rotation after rotation, V parallel, it remains same, plus V perpendicular rotation, this one vector, but it has two components. This is the circle which is in the plane perpendicular to omega cap. This one initially perpendicular here, they are rotated by this way. So it has two components. This one V perpendicular cos theta, this one V perpendicular sin theta. V perpendicular cos theta is in the direction of original V perpendicular. So it is V perpendicular cos theta. It gives direction also. But we after rotation this one V perpendicular sin theta by magnitude. But it is not in the direction of this one. It is in the direction perpendicular to omega cap as well as V. So we have put mod of V perpendicular into sin theta, but direction we require. V parallel is this. It is in the direction of omega cap. So component of V, it is nothing but V dot omega cap upon mod omega cap into omega cap. This one formula we have applied. Plus V perpendicular cos theta. V perpendicular is V minus V parallel cos theta. Now we have to replace V perpendicular. This is magnitude only. We require direction also. So this one after rotation, this is the direction of omega cap cross V. Omega cap cross V. It is the direction of this one. So we put this one. We will replace V perpendicular by V omega cap cross V into sin theta. But magnitude must be same exactly this. See here. Omega cap cross V is mod omega cap mod V into angle between them sin phi. Omega cap is one unit vector. So mod V sin phi. It is exactly by magnitude V perpendicular. So magnitude is also adjusted and direction also. So finally this plus this plus this. This one is as it is. V as it is minus V parallel. Again V minus V perpendicular. This one, sorry, V minus V parallel. V parallel is this one. So omega cap dot V into omega cap. V parallel is this one into cos theta. This one as it is. Now this one V cos theta I have written first. This one and this minus this one cos theta. So taking common cos theta, we get omega cap dot V into omega cap into 1 minus cos theta, and the last term is I have adjusted in middle. This is the Rodrigues formula for rotating a vector about a random axis. I think in 1840 that work done by Rodrigues. Thank you. Now using Rodrigues geometric formula for rotating a vector around a random axis, we want to find a rotation matrix. See here, V rotation is V cos theta omega cap cross V sin theta plus omega cap into omega dot V into 1 minus cos theta. We have obtained this. I want to write above in terms of R into V. Then R is called rotation matrix. Let V is V1, V2, V3 and omega cap is omega 1, omega 2, omega 3. The first term V cos theta. So cos theta into V1, V2, V3. The third term omega cap into omega cap dot V into 1 minus cos theta. But what is omega cap dot V? Omega is omega 1, omega 2, omega 3, V is V1, V2, V3. So omega 1 V1 plus omega 2 V2 plus omega 3 V3. So omega cap into omega cap dot V. Omega cap is omega 1, omega 2, omega 3. Omega dot V is this one. Omega V1 plus omega 1 V1 plus omega 2 V2 plus omega 3 V3. So multiplying all the terms, omega 1 square V1 plus omega 1 omega 2 V2 plus omega 1 omega 3 V3. Omega 2 omega 1 V1 omega 2 square V2. Then after omega 2 omega 3 V3. Omega 3 omega 1 V1 omega 3 omega 2 V2 omega 3 square V3. Separating V, this one, we can write matrix point of view. Omega 1 square omega 1 omega 2 omega 1 omega 3 omega 2 omega 1 omega 2 square omega 2 omega 3 omega 3 omega 1 omega 3 omega 2 omega 3 square into V. Thus omega cap into omega cap dot V into 1 minus cos theta, 1 minus cos theta as it is, and for this we have obtained. So this is the same. Step 3, second term. So omega cap cross V into sin theta. So omega cap cross V I is AK omega 1 omega 2 omega 3 V1 V2 V3. So I cancel this one omega 2 V3 minus omega 3 V2. J cancel, but minus 1 is there, so we have put this one again. Omega 3 V1 minus omega 1 V3, and this one omega 1 V2 minus omega 2 V1, this one. So the term becomes sin theta into this using matrix property, special one, any student should know, must know. We can write this term as 0 minus omega 3 omega 2 omega 3 0 minus omega 1 minus omega 2 omega 1 0 into V sin theta. So omega cap cross V sin theta is sin theta into this vector into V. Now so from Rodrigues formula, V rotation is V cos theta plus omega cap cross V sin theta plus omega cap into omega dot V 1 minus cos theta. So cos theta into 1 0 0 0 1 0 0 0 1 identity matrix V is V1 V2 V3 sin theta as it is omega cap cross V we have obtained this one into this and 1 minus cos theta into for this it is this one matrix into V1 V2 V3 we have obtained already. So we can separate here this from this term V, this term V, this term V. So V rotation is RV, separating V, R rotational omega cap theta. If you rotate vector around random axis omega cap up to angle theta, the rotation matrix is cos theta into I, V is separated, sin theta into this, and 1 minus cos theta into this. So we have obtained the rotation matrix.